Today, let's learn about something cool, the Van de Graaff generator. But first, what is an electrostatic generator? An electrostatic generator is a machine that builds up and stores static electricity, the same kind that gives you a little shock when you touch a metal door or makes your hair stand up after rubbing a balloon on your head. The Van de Graaff generator was invented in 1931 by a physicist named Robert J. Van de Graaff in the United States. He built it to create very high voltages for experiments in physics, especially to study the tiny particles inside atoms. Let's take a closer look at the construction of a Van de Graaff generator. It's made of several important parts, all working together to build up static electricity. Here's what it consists of, in order. Hollow metal globe. This is the large metal dome at the top. It stores the electric charge collected by the generator. The bigger the globe, the more charge it can hold. Insulated column. This is the tall stand that holds everything up. It's made of an insulating material so that electricity doesn't escape through it. Ground. The bottom part of the generator is connected to the ground. This helps push electric charge onto the belt using a process called induction. Spherical device, discharge sphere. This is a small metal ball placed near the main dome. It's used to safely discharge the stored electricity, often seen as a spark. Upper roller, metal. Inside the dome, there's a metal roller at the top. It helps guide the belt, and also plays a role in collecting the electric charge. Lower electrode. This is a metal comb or brush near the bottom of the belt. It helps charge the belt using electricity from the ground. Upper electrode. This is another metal comb near the top roller, close to the dome. It collects the charge from the belt and passes it to the globe. Rubber belt. A rubber belt moves in a loop between the two rollers. It carries electric charge from the bottom to the top of the generator. Lower roller. The roller at the bottom is made of an insulating material. It helps create a charge difference when the belt moves over it. Together, these parts make up the Van de Graaff generator. A simple machine that creates powerful static electricity. Now that we've seen how it's built, let's understand how a Van de Graaff generator works, step by step. First, the motor turns the rollers, which makes the rubber belt start moving inside the generator. As the belt moves over the rollers, friction is created, and this friction generates electric charge. The lower electrode near the roller uses this friction to pull electrons off the belt, or push them onto it, depending on the materials used. This leaves the belt carrying a charge, usually positive. The rubber belt carries this charge upward, toward the metal dome at the top of the generator. At the top, another electrode collects the charge from the belt, and transfers it to the hollow metal globe, where it builds up over time. When the potential difference, the voltage, between the globe and a nearby discharge sphere becomes very high, the air breaks down and a spark jumps across. Then the cycle starts all over again, with the belt moving and the generator continuing to build up more static electricity. Ever seen someone touch a Van de Graaff generator, and suddenly their hair stands on end? Let's break down how that actually works. This is a Van de Graaff generator. It uses a moving belt, pulleys, and metal brushes to build up static electricity. All the positive charges collect on the outer surface of the metal dome. Since the dome is a conductor, the charge spreads evenly on its surface. When a person touches the dome, and they're not connected to the ground, the charge moves onto their body. Now, their hair also gets the same kind of charge, let's say, positive. And here's the fun part. Since like charges repel, each strand of hair pushes away from the others, making it stand up and spread out. Now look at this. As we slowly bring the discharger close to the person's head, their hair starts to bend and get attracted towards it. This happens because the discharger has an opposite or neutral potential, and the hair is pulled by electrostatic attraction. And here's something fun. When this second person reaches out and touches the charged person, a small spark jumps between them. Both people feel a quick jolt. That's the static electricity discharging. This spark happens because there's a sudden movement of electrons. The system is trying to balance the difference in electric charge. Alright, now let's see some live